Hello everyone, myself Nayana Reddy. I'm studying in Sri Venkateshwara College of Engineering. In this video, I'm going to explain about applications of curve fitting. The topics to be covered are introduction, curve fitting, various methods of curve fitting, types of curve fitting, algorithm of curve fitting, example, applications of curve fitting. First, we can see about the introduction. All engineering experiments land into collection of data which has discrete values. This section deals with techniques to fit curves to such data in order to obtain intermediate estimates. The simplest method for fitting a curve to data is to plot the points and then sketch a line to visually conforms to the data. In many engineering and science applications, it is required to express the data obtained from various observations and experiments in the form of law. The law gives mathematical relationship between the two variables is called empire law. This is the example of the curve fitting. Curve fitting. Curve fitting is a process of constructing a curve or mathematical function that has the best fit to a series of data points, possibly subject to constraints. Curve fitting can involve either interpolation, where an exact fit to the data is required, or something in which a smooth function is constructed that approximately fits the data. A related topic is recursion analysis, which focuses more on questions of statistical inference, such as how much uncertainty is present in a curve that is fit to data observed with random errors. Fitted curves can be used as an add of data visualization to infra values of a function where no data are available and to summarize the relationships among two or more variables. Extrapolation refers to the use of a fitted curve behind the range of observation data and is subject to a degree of uncertainty since it may reflect the method used to construct the curve as much as it reflects the observed data. Next, we can see what are the various methods of curve fitting. If there are different values of x and the various corresponding values of y, then a mathematical relationship y is equals to f of x between these two variables can be obtained by graphical method, method of group averages, method of movements, method of least squares. These are the various methods we will use in the curve fitting to find the curve fit values. Next is fitting lines and polynomial functions to data points. The first degree polynomial equation is y is equals to ax plus b is a line with a slope a. A line will connect any 2 points, so a first degree polynomial equation is an exact fit through any 2 points with distinct x coordinates. If the order of the equation is increased to a second degree polynomial, the following result is y is equals to x square plus bx plus c. This is the second degree of the polynomial. This will exactly fit a simple curve to 3 points. If the order of the equation is increased to a third degree polynomial, the data is following is obtained by y is equals to ax cube plus bx square plus c x plus d. This will exactly fit 4 points of the third degree polynomial. A more general statement would be to say it will exactly fit for constraints. Each constraint can be a point, angle, or curve, which is the reciprocal of the radius of an circle. Angle and curve constraints are most often added to the ends of a curve and in such cases are called end conditions. The first degree polynomial equations could also be an exact fit for a single equal point and an angle, while the third degree polynomial equation could also be an exact fit for 2 points, an angle constraints and curve constraints. Next, two types of curves. One is square regression, another one is polynomial regression. Least square regression given to data for discrete values derive a single curve that represents the general trend of a data when the given data exhibit a significant degree of error or noise. Interpolation given a data for discrete values fit a curve or a series of curves that passes directly through each of the points when data are very precious. First one is simple linear regression, fitting a straight line to a set of paired observations, mathematical expressions for the straight line model. Y is equals to a0 plus a1x, where a0 is a intercept and a1 is a slope. Define it, ei is equals to yi measured minus yi model is equals to yi of a0 plus a1. This is next one is polynomial recursion. Polynomial recursion gives data of xi and yi, or I is equals to 1 comma 2 to the 1 to the n number of values. Fit a second order polynomial. Next is curve fitting algorithm. Curve fitting, the process of constructing a curve or mathematical functions that has the best fit to a series of data points, possibly subject to constraints. Curve fitting can involve either interpolation where an exact fit to the data is required, or smoothing in which a smooth function is constructed that approximately fits the data. A related topic is recursion analysis, which focuses more on questions of statistical inference, such as how much uncertainty is present in a curve that is fit to data observed in random errors. Fitted curves can be used as an aid for data visualization, to infer values of a function where no data are available, and to summarize the relationships among two or more variables. Next, we can see the example problem. Let us see the question. Fit a straight line to the x and y values in the following data. In this table, x and y, they will be given. X has 1 2 3 4 5 6 7 until 7, 1 to 7, and y values they are given as 0.5, 2.5, 2, 4, 3.56, 5.5. And after this we need to add x values, all that we get as a sum of 28. And y values, if we add the y values, we will get 20, sum of y is equal to 24. After adding this both, we have to calculate y value. We need to calculate x into y, so that we will get xy values. 1 into 0.5 is 0.5, 2 into 2.5 is 5, 3 into 2 is 6, so on. We need to calculate. After multiplying both x and y, we will get the sum of xy value as 119.5. Next, after calculating x into y, we need to calculate as x square, sum of x square. Sum of x square we will multiply as 1 4 9 16 25. That will get as a sum of x square is equals to 140. After all calculating the x y x y and x square, we need to find the straight line. For straight line we need to find, means we have to know the formula of x. X is equals to sum of n numbers. N number is 7, and sum of x values. 28 divided by 7 is nothing but 4. And after finding the x, we need to see about y. Y having n number has a 7, and sum of y is 24. 24 divided by 7 is nothing but 3.42857. Next example we can see about using a method of least squares fit curve is equals to ax to the power of b. Following table, here they given x and y. We need to calculate how n numbers. This is n numbers, 1 2 3 4. These are the n numbers. We in this example, we need not to calculate the x and y. We need to calculate as a x y and x square and xy. X log of x e to the power of log, we need to calculate it. After calculating all the x square and xy, we will get a sum of x and sum of y and sum of x square, sum of xy. After getting all this, we need to calculate. As a xy formula as a of summation x plus nb, summation xy is equals to a of summation x square plus b of summation x. These are the normal equations of this problem. Here here we will get the a value has 0.171708, and b value 6.5539. After getting a value, we the a value is in the capital A, so that we need to calculate for a small a, so that we can take as e to the power of a. E to the power of a is equals to e to the power minus 0.1780. If we calculate, we will get answer as 70197. At last, we need to write as a y is equals to 701.97x power 0.1708. Next, applications of curve fitting. Fitted curves can be used to help in data visualization, predict functions values when no data is provided, and describe the functions between two or more variables. They are used in architecture to design arcs, buildings, and cooling towers in power plants. Curves such as parabolas and hyperbola are referred as a conics. Filling in missing data points such as when one or more measurements missing or immediately recorded. This is about all whatever I explained about a curve fitting. I hope you all understand about curve fitting. Thank you.